In the previous two videos, we introduced the 5 most important targets of architectural analysis and discussed when the analysis should be performed. In the next few minutes, we'll look at the criteria that must be used for architectural analysis, the methods that can be applied, and how to document the results properly. Let's start with the criteria. In practice, architectural analysis evaluates the following aspects. Suitability. This criteria check whether the architecture is the right solution. Second, feasibility. This criteria assess whether the architecture can realistically be implemented. Point number 3 is verifiability. This criteria ensures that the architecture can be verified and tested. Then we have maintainability for software. This criteria assess long-term suitability, focusing on principles such as separation of concerns, modularity, and solid principles. Then we have documentation quality, what I call comprehensibility. Since the object under analysis is the documentation itself, quality criteria are mandatory, such as correctness, completeness, and understandability. Robustness. This criteria focus on the behavior under stress or failure. Safety. When functional safety applies, architectural analysis includes safety-specific criteria such as freedom from interference and avoidance of dependent failures. Cybersecurity. For cybersecurity, architectural analysis focuses on weaknesses such as attack surface exposure, trust boundaries and secure communication paths, authentication, authorization, and so on. In Automotive SPICE, criteria must be explicit and well formulated. They must leave no room for interpretation. For this reason, I recommend creating a checklist or guideline with clear specific criteria that are applicable to your product, based on the aspects we just discussed. An example: are all software components assigned to tasks or execution contexts? This is about scheduling and technical feasibility. Let's talk now about architectural analysis methods. There are several possibilities. First, we have reviews. You walk through the architecture and check it against the criteria we discussed earlier: feasibility, suitability, documentation, design decisions, interface description, dynamic behavior, and so on. You discuss trade-offs, and for cybersecurity, you look at trust boundaries and potential attack surfaces. Different review types can be applied, such as peer reviews, walkthrough, or technical inspections. These review types must be clearly defined in advance and applied consistently. If you want to learn more about software reviews, refer to the IEEE 1028 standard for software reviews and audits. Next, there are simulations and calculations. These provide a realistic preview of performance and potential bottlenecks without the need to build the full product. Remember, the goal of a simulation is to check whether the architecture is the right solution for the requirements, so that the system behaves as expected, and to identify potential risks. Here, it's essential to clearly define the targets of the simulations and calculations, along with pass-fail criteria. Too often simulations are performed just to see how it works, without a clear objective. This is simulation against nothing and should be avoided. Also remember to produce reports out of simulations and calculations as a basis for further decisions. Then we have prototypes. These support architectural analysis by providing an early, tangible way to validate design decisions and system behavior. They help identify new requirements, risks, cybersecurity weaknesses, and potential safety issues, while also allowing measurement of timing, resource usage, and interactions between components. Finally, we have failure and risk analysis. Using methods like FMEAs or FMEDAs, we identify weak points, single points of failure, or error handling issues. We also perform preliminary safety checks for ISO 26262 and cybersecurity vulnerability analysis for ISO 21434. And now let's look at how architecture analysis results should be used and documented. This is important because architecture analysis usually combine multiple methods such as reviews, FMEAs, simulations or calculations, and each of them produces valuable information that must be managed and made accessible. Start with decisions and rationale. Clearly record the major architectural decisions and the reasons behind them. Reference proven architectures, reuse decisions, and technical trade-offs. Typically, these results are either a part of the architecture documentation itself or linked from it. Next include assumptions. These are conditions you rely on, such as available resources, expected workloads, or supplier availability. Being explicit helps everyone understand the context. Assumptions are documented to be discussed, confirmed or contradicted, not just to remain on paper. They must be tracked and acted upon. Then document potential risks. Could a decision impact schedule or costs? Could it create integration challenges? Identified risks, both managerial and technical, should be added to the risk list and managed according to the main file process. Finally, in case where functional safety or cybersecurity is relevant, architecture analysis can trigger changes to the safety concept or to the cybersecurity concept. These changes must be traced back to their source. Very often this traceability, for example to FMEAs, is not done properly. Always keep traceability in mind. Architecture analysis often lead to new or updated requirements, which must be traceable back to the analysis. They can also feed verification activities, for example by defining system behaviors that need to be tested on the real hardware. In conclusion, properly documenting architecture analysis results ensure that decisions, assumptions and risks are visible, traceable and actionable. This supports project planning, risk management, implementation and verification. That's all for now. In the next video, we'll take a deep dive into a topic that is especially relevant for assessors. What to look for during an assessment, which questions should be asked, and how to correctly map evidence to best practices and generic practices. If you like this video, share it with your colleagues and subscribe to my channel to learn more about Automotive SPICE. Thanks for watching and see you in the next video.